Today we're looking at section 1.4. Our objective today is I can use geometric definitions applying to angles. So our first definition is that of an angle. Okay, so an angle is defined as a figure formed by two rays with the same endpoint. The symbol for angle is just a miniature angle, and the way that we name an angle is we can name it with a number. Number two, we can name it by the 3 points that form it. And number 3, but you have to be very careful with number 3. You can only do it in certain situations. You can name it by its vertex point. But you can only use this one if there's only one angle at that vertex point. In other words, there cannot be any question about what angle you're talking about. Okay, so here's ray AB and ray AC. Okay, so ray AB and ray AC form angle BAC. We can also call this angle 1. Okay, and because there's only one angle here, we can just say angle A. So we could say angle BAC. Note that the vertex always has to be in the middle when you name use 3 points to name it. We could say angle 1, and in this case, because there's only one angle there, we can say angle A. So those are the ways that we can name it. Okay, the vertex is the common point shared by the two rays that form the angle. Okay, so again, let's say I have this picture. This is A, B, C, D. Okay, so, and this is angle 1, angle 2. So I could talk about angle 1. Okay, so in that case, if I'm talking about angle 1, I am talking about this angle formed by ray BA and ray BC. I could also talk about angle 2. I could talk about angle ABC, which is another name for angle 1, or I could talk about angle CBD, which is another name for angle 2. But I could also talk about angle ABD. So notice that in that picture there's actually 3 different angles that we could talk about. The sides of the angle are the two rays that form the angle. Okay, so ray BA is the side of angle 1. Ray BC is the side of the second side of angle 1. Ray BC is also a side of angle 2, and ray BD is the side of angle 2 also. Okay. A protractor is a tool used to measure the degrees of an angle. And they usually look like a half circle. Oops, not very good, half circle. And then there's angle measures on the protractor. Okay. Types of angles, because we can measure the angle, we can relate them as in terms of the measure of their angles. So an acute angle has a measure. The angle measure is between 0 and 90 degrees. Okay? And in math we would write that if x is our angle, x would have to be greater than 0 degrees but less than 90 degrees. Okay? And notice that 0 and 90 are not included. Right? So an acute angle might look like that. Okay? Then we have a right angle. A right angle is an angle whose measure is exactly 90 degrees. Okay? And the way that we would write that mathematically, if x is our angle, then x equals 90 degrees. And in a picture, we denote a right angle with a box. So anytime you see a box with an angle, then you are being told that it's a 90-degree angle. An obtuse angle is an angle whose measure is between 90 and 180 degrees. Okay? So in math, if x is the angle, x is greater than 90 but less than 180 degrees. So notice again that it's never equal to that. So if this angle is x, this would look like an obtuse. I'll put my x's in there, okay? And then the one that most of us tend to forget about is the straight angle. And the straight angle is an angle whose measure is exactly 180 degrees. So x equals 180. So a straight angle would look like this, and its measure would be 180 degrees. And then there's the protractor postulate, and I'm not going to write it out here. You can see it on page 18 of your book if you want to read it. But it's similar to the ruler postulate in that it just states that angles can be measured. Okay. Then we come to the angle addition postulate. This one is a very, very important one, so highlight it. This is one that you must know and that we use over and over again. And it says, the hypothesis says that if B lies in the interior of angle AOC. So you have some angle AOC, and in the interior would be in here. So B has to be in here someplace. Okay? Then, if that is true, if B lies in the interior of angle AOC, that's our hypothesis. If we have this, then for sure this is going to be true. Okay? So, if we draw a ray through that, then measure, this is angle 1 and angle 2. So measure of angle AOB plus measure of angle BOC must equal measure of angle AOC. Okay? Or we could say measure of angle 1 plus measure of angle 2 has to equal measure of angle AOC. Is another way to say that. But notice again that B must be inside the angle. And then there's a second part to the angle addition postulate, because if there's a straight angle, we can't talk about B being inside. So here's A, O, C. So we have to talk about B being a point that is not on, whoops, this needs to be line. It is not on line AC. So B could be up here. And if we draw a ray through B, we get angle 1 and angle 2. And so in this case, measure of angle AOB plus measure of angle BOC has to equal 180 degrees. Or measure of angle 1 plus measure of angle 2 equals 180 degrees. Then we have congruent angles. And congruent angles are just angles which have the same measure. Okay? So measure of angle A equals measure of angle B. So if we're talking about the measurement, they're equal. And because they're equal, now we can say angle A is congruent to angle B, because they're both angles and they both have the same measure. Now we can say that they are congruent. They meet the two conditions. Adjacent angles are two coplanar angles with a common vertex and no common interior points. Okay, the symbol we use to denote is just ADJ with the angle symbol. Okay, so an example of this here's A, B, C, D, E, right? So we can say that angle ABC and angle CBD, let me erase that. Oops. Are adjacent angles. But because they share a common side, but they have no common interior points. But if I say angle ABD and angle CBE, those are not adjacent angles because they share all these points in between. So we cannot say that those are adjacent angles. Okay, because they share points. And then finally we have an angle bisector. And the angle bisector, or bisector of an angle is a ray, must be a ray, that divides the angle into two congruent angles. Okay, so I kind of ran out of room here, but if this is angle A, B, C, and we have ray BD, and this angle is 30 degrees, and this angle is 30 degrees, then we know that we have congruent angles. Okay, because measure of angle ABD is equal to measure of angle DBC. So therefore, angle ABD is congruent to angle DBC.